Okay, we are on the part one discussion where we're identifying changes that we observe as being physical or chemical changes. Physical changes are when you have a change of state. So you convert a solid to a liquid or a gas, or you go the opposite direction. That means that the composition did not change. We still have the same substance. Chemical changes are when you create something new, and there are a few observations that you might make during a chemical change. An unexpected color change, the formation of a gas, heat is absorbed or released, or the emission of light is a less common one. But if you take a look at question number one, it says, select one of the changes you observe that your group thinks is physical in nature, then complete the following. So a physical change that we observed would be an example of something like the wax melting, right? Because it went from a solid to a liquid, but it was still wax. The composition didn't change. Something that you may want to note about physical changes is physical changes tend to be reversible. Okay? You could have also picked the water heating. We were producing some water vapor. It was still water, it was just in the gas phase. If you're going to represent wax melting as a physical change using a particle diagram, so before you had these chunks of like globular pieces of wax, right? And then after the wax sort of spread out, there was more surface area, right? It was flatter, it was kind of softening. Same color, it was just more liquidy, okay? Describe the physical change using words or chemical symbols. Well, the wax melted, it changed from a solid to a liquid. It was softer, it was sort of runnier. The particles appeared to be more spread out, and they were sort of sliding over each other. But it was still wax. The composition was the same. If you take a look at number two, select one of the changes you observe that your group thinks is chemical in nature, then complete the following. So the chemical change that you chose, well, there were a couple of chemical changes that we observed. One of them was where we had the copper 2 sulfate, pentahydrate heating. Okay, because when we heated it, there was an unexpected color change. It went from sort of a dark, really gorgeous, pretty blue to this lighter bluish white, almost there were some gray bits in it, or maybe light brown. And what was happening was, before, you had these little blue crystals. They were all uniform in shape, right? All the same color, and then after you heated it, I can't do this with a green marker, but after you heated it, the color changed. The crystals appeared to be the same shape, but their color was different. So these were all blue. These were turning colors into, they were white, almost, some of them were like a light blue, some of them had like a light brown and a gray appearance on a couple of them. Okay, so describe the chemical change using words or chemical symbols. Well, when the copper 2 sulfate pentahydrate was heated, it actually released the water that was attached. So the waters that were attached to this chemical formula, those waters left, and that's how we got this change in color. So you were losing it, and now we just have copper 2 sulfate. So that you could explain, that was the chemical change. We were releasing something and producing something different within your description. Now, if you wanted to use the ethanol being heated because it was flammable, it produced a flame, it produced heat and light, you could also use that as one of your chemical changes. Something that you may want to note here is that chemical changes tend to not be reversible. Take a look at the next page at number 3. So we want to think about the changes at the particle level. We want to identify the changes observed as being physical or chemical and explain each choice at the particle level. So for number 1, you had liquid water. Heated it, it went from the liquid to the gas phase. It was still water, so that was a physical change. There was no composition change. Particle level explanation. Well, if you have liquid particles versus gas or water vapor, remember that the particles are going to be much further away from each other in the gas phase and just kind of randomly moving, right? And then the liquid particles, those particles are going to be more compact. They'll be touching. They can slide over each other, but they're a little more restricted, or a lot more restricted, you could say, than the vapor. Number 2, ethanol. Well, we had a flame, there was a color change, and there was heat generated. This was a chemical change. And you were going from the liquid to the gas phase. I will let you do the particle level explanation using the example that we did in number 1 for water. Sodium chloride, NaCl solid. So we took the sodium chloride and we put a match up to it, and it changed colors. It changed to a brown color, and it sort of melted onto the aluminum tray. So think of this as being reversible. Could we just magically reverse that and make the sodium chloride turn back to its original color? I would say not. So this would be a chemical change. I'm going to let you fill in the particle level explanation on that. For the sucrose, when we burned the sugar, it smelled sweet. It changed colors. This was a chemical change. Number 5, the wax, it melted. Physical change. For 6, 7, and 8, I'm going to let you fill these in as to whether or not you feel like these are physical or chemical changes, and I want you to provide all the particle level explanations and justifications on that. And then for number 4, give a tentative definition for a physical change and a chemical change.